Welcome to Green TV, the show dedicated to positive Green New Deal solutions and the candidates that advocate for them. I'm your host, Gail Parker. Green TV is about Green New Deal eco-jobs for the economy, positive solutions, eco-capitalism, prices must tell the environmental truth. It's about the green industrial revolution, solar jobs, wind jobs, geothermal jobs, rail jobs, weatherization jobs, conservation jobs, efficiency jobs, lots of jobs. It's about building green neighborhoods, walkable, bikeable, pedestrian, and rail-friendly communities. It's about having cleaner air and cleaner water, cutting taxpayers' subsidies to zero for fossil fuel, big oil, big auto. Rail built anywhere in America benefits all of America. Renewable energy is free energy, clean energy. On today's show, we are continuing our focus on solar energy. Today, we feature Stanford University's clip on why solar energy is the future. Watch and learn if solar energy is recommended for your location. But first, this is what one woman is doing about corruption in her neighborhood.
Hi, this is Sherry Honkala, and I'm running in the 197 in Philadelphia, Pennsylvania for state representative. The last two reps have resigned because of corruption, and the last state rep that was running, Freddie Ramirez, I'm happy to say is off the ballot because he doesn't live in this neighborhood. We're going to end the legacy of corruption on March 21st, and I need you to join me. Join this coalition. Hashtag We Are the 197. Also go to my website at sherry197.com. I'm telling you guys, it's time for all of us to decide whose side we're on. Are we going to side with the actual residents and neighbors and people that are trying to uplift their lives? Join me. We are the 197.
And now this on solar panels.
Every hour the sun's energy falls on the planet is equal to the amount of energy used by the entire human population in 1 year. The energy from the sun is in limitless supply. Unlike oil or gas, solar power is a reliable source of energy whose prices never fluctuate. Solar energy is free. How does it work? Solar electricity is generated using photovoltaic cell technology that has been optimized over years of research. Simply put, the greater the intensity of the sun, the greater the current of electricity. Solar panels collect sunlight and turn it into direct current or DC electricity. Even on cloudy days, your panels will absorb sunlight. The system's inverter then turns this DC electricity into the same electric current that comes from your traditional utility lines. Your solar electric system is connected directly to your utility power supply so that the excess power from your solar panels will be fed back to your local utility company. Why BEP? We offer incredible cost savings and an easy installation process. We'll handle everything from planning and installation to getting you all available federal and local incentives. With BEP, switching to solar is easy, affordable, accessible, and a smart investment. Contact us for your free site assessment and consultation. Get in touch with us today to learn more about our no money down, no interest for a year special offer. Solar energy. Our planet needs it. Your future needs it. Your business needs it.
It's been really exciting over the last several years to see the solar industry finally take off. Here in the red curve, you see the price of solar cells as a function of time. Back in the 70s, it was about $100 per watt that you can get from a panel at noon under peak sunlight. And that dropped, and then there was a stagnation where There was very little interest in renewable energy, and so not a lot of research. And then more recently, the prices have dived, and now it's down at around 50 or 60 cents per watt. And in a slide or two, I'll put that number into perspective for those of you who don't follow these numbers. But as, well, you can kind of get an idea that things get interesting at about $1 per watt, because when it got there, that's when the market really took off. And now about 65,000 megawatts are installed each year, which is about the equivalent of 65 large coal-fired power plants. So we still have a long way to go, but things are taking off and growing, around 30 or 40% per year, which is very large for something that requires manufacturing. And I probably don't need to say it this week, but I think we're at a tipping point. People are taking climate change very seriously now all across the board, which is good for the solar industry. Solar cells are primarily deployed in 3 sectors: on homes, and generating the power right where it's used, on large buildings in the commercial sector. You can reduce the installation costs as you go to these larger installations. And then you get the best cost when you go out to the utility scale. And we're seeing a lot of this in California. If you ever fly from Phoenix to San Francisco, keep an eye out the airplane, and you'll see a lot of this stuff out in the desert. And here you can see from Department of Energy some of the numbers. And on the residential scale, if you know the dollars per watt, you can calculate the cost of the electricity over the lifetime of the project to get what we call the levelized cost of electricity. And without a subsidy in the residential scale, right now that's around 20%. But currently we do have a 30% subsidy, and that brings it down to 14. DOE has set a goal that needs to get to 8. That's when people would use solar, pretty much everywhere. But here in California, most people pay more than that. And as a homeowner, I get an electricity bill, and around here we have tiers, and up to a certain amount of electricity, you're in tier 1, and then you go to tier 2. Tier 4 around here is 40 cents per kilowatt hour. And if you ever use your air conditioner, you get into that. And so solar is very popular around here. And what I think is going to happen is electric cars are going to become more and more popular. Eventually, companies are not going to allow people to charge up for free. I know of no employer that has a gas pump in the parking lot and allows people to have a free fill-up whenever they want it. So that's not going to continue with electricity. People are going to have absolutely ridiculous electricity bills at home when they have an electric vehicle. And anyone who's smart enough to be able to afford a Tesla will be smart enough to switch to solar at that point. And so I think it will really take off. Maybe skipping ahead to the utility scale, you see the prices come way down because it's just easier to do these large installations. Here, the permit can be really expensive, and it's not divided out over a whole lot of watts. Here, it can get divided out of megawatts of power that are generated. And you see that but we still have maybe a factor of 2 or 3 to go in the cost reduction, so the job is not done. At this point, and you kind of get the difference between these two is not technology, it's the balance of systems. And you're getting a hint that the installation is now a really significant part of the cost. It's probably about 75% here and maybe half there. And so there certainly needs to be work in more efficiently installing the systems. It's not what I do, so it's not what I'm going to talk about today. But what people can do who make panels is they can just raise the efficiency. and then you don't have to install as many panels, and you effectively lower the balance of systems. And also, before I say more about that, you know you've arrived somewhat when you're finally covered in Consumer Reports. And Consumer Reports now recommends that if you live in a white state, you should go ahead and buy solar. You will save money if you do that. But in the blue states, either there's not as much sunlight, or electricity is so cheap there that right now you'd still be better off. So this drives some of the need to go to higher efficiency. And here you can see the efficiency of some of the best technologies. I'll start with black, because that's silicon, and that's about 92% of the market. You can see it is one of the more efficient technologies, but there's also hardly been any improvement in efficiency for about 18 or 19 years. There's been improvement in manufacturing to bring costs down, but not improvement in efficiency. Gallium arsenide is better, but it's about 40 times more expensive, and I personally don't think that's going to change, but some people disagree with me. Down here are thin film technologies, where you just have a very thin film of semiconductor on something like glass, and it brings the costs down. And traditionally, it's been copper, indium, gallium selenide, and cadmium telluride that were the leaders. And then, and they get the other 8% of the market. And then out of nowhere, Perovskites arrived about 4 or 5 years ago. I was fortunate to be directing the center that made that discovery, and so I knew about it right at the beginning. And what's awesome about Perovskites is we can print them. You could imagine taking an old film factory or an old newspaper factory, tweaking the tools a little bit, and printing solar cells on plastic. And I've been working on that for about 16 years, but our efficiencies were always way down here. And now we have caught up, and we can print 22% efficient solar cells. But I believe very high efficiency is where things need to go. We've done some calculations, as have other people, and we find that when you can raise the efficiency by 1 point, you improve the value of the module by 3 cents per watt. So in other words, if we can go from 20% efficiency to 25%, instead of paying 50 cents per watt, you should be willing to go up to 65 cents per watt because of all the extra power. And then you can look in the market, and there are products with a range of efficiencies, and you can find out what are the selling prices. And of course, the utility companies know what they're doing, and it indeed is exactly 3 cents per watt is the extra value. And we find that in a place like Palo Alto or Menlo Park, it turns out it would make sense to pay like $1.50 per watt. That may seem crazy, but yeah, if you have a Tesla, you want to do anything you can possibly do to avoid paying the 40 cents per kilowatt hour price, but your roof is not big enough to meet your electricity needs, so you need to get the most efficient product you can get your hands on, and it's worth it to pay well over $1. And that's why I believe there's a strong demand for a high efficiency product. Let me say a little bit about semiconductors for those in the audience who don't know much about them. They're interesting materials where there are a whole bunch of energy levels that electrons can go into, and this is called the valence band, and it's filled with electrons. Then there's a gap where there are no energy states, and above it there's a conduction band with mostly empty levels. When light is illuminated on these materials, you can excite an electron up into the conduction band. The lack of the negative charge creates what we call a hole with positive charge. And until that electron falls back down, the energy is stored. And if we can somehow coax the electron to go to one side and the hole to go to another, then we're able to extract that power and generate electricity. And when we do this, we want to get the highest current and voltage we can. And to get a high voltage, we want the band gap to be large, because if we excite the electron high up into the band, when it'll fall to the bottom of the band and we'll lose all that energy. And the voltage is somewhat related to that energy gap. And the larger it is, the higher the voltage we can get. So that may imply that we want a large band gap. The problem with that is we can only absorb photons if they have a greater energy than the gap. So if we pick a large gap, then a lot of the photons in the solar spectrum will go right through the solar cell unabsorbed. So when you look at the trade-off, you find the efficiency versus band gap looks like that. And the ideal band gap is 1.4 electron volts, and you can only get about 33% efficiency. But that's with one semiconductor. The way to do better is to have two semiconductors and use one of them to harvest the high energy photons. That'll have a higher band gap, and that cell can generate a higher voltage than silicon can do. And then you can have also a lower gap cell to capture another part of the spectrum. And you can do even better with 3 or 4 or 5. However, as you add layers, the cost will go up. And so I personally think 2 layers is ideal. And so I think that we can go from a practical limit of around 25 to something up in the range of 30 to 35 if we do this. And this definitely works. The world record solar cell has 46% efficiency. It has 4 solar cells stacked on top of each other. I personally think it is the most advanced semiconductor device that's ever been made. It costs well over $40,000 per meter squared, compared to about $80 per meter squared for silicon. So there's certainly no way you can cover rooftops with this, although they are great for powering satellites and space stations. But I think it just demonstrates the concept works, but we cannot be using single crystals that are grown very slowly with a technique called molecular beam epitaxy. Instead, we need an inexpensive material that works well even when it's defective. And that's where the Perovskites, I think, come in. And the Perovskites have the right band gap. And it turns out for the bottom solar cell in a tandem, silicon, which is already the market leader, has the right band gap. And so we can just put Perovskites right on top of silicon. Here's what the Perovskites are. This is the crystal structure. And the compound that generated a lot of excitement is methylammonium lead iodide. But it's all tunable. And here, if we switch from iodide gradually to bromide, you can see the color changing. That's because the band gap is increasing from 1.6 electron volts to 2.3. Over here, all visible photons are absorbed, so it looks black. And over here, the red photons are not being absorbed, and that makes it look red. 1.8 EV is perfect for the tandem, and so you see that right in there is the right compound for that. And you can also replace methylammonium with something called formamidinium, and that will drop the band gap. Only have 20 minutes, so I'll just skip right to it. We got our certified world record about 2 weeks ago. When you think you have a world record, you send it to the National Renewable Energy Lab, and they test it, and they confirmed. And we're at 23.6% efficiency now. And we needed to do one more thing to beat silicon's record, and I got the text on Saturday that that's done. And 25.6 should fall at some point in the next few weeks, I think, which is going to be really exciting. If you join my group, there's 2 ways to get one of those 26.2 stickers. The easy way is to run a marathon. The hard way is to make a solar cell with 26.2. Kevin Bush is definitely pursuing the hard way, and he's possessed, and he's hunting it down. And I hope we'll get to 30 in the next couple of years, and I think we will. Another breakthrough, and I think this is going to be accepted in science this week. We figured out how to do a low band gap perovskite. We sprinkled in a little bit of tin to replace some of the lead. We dropped the band gap down to 1.2 electron volts. And here's a side structure of the first all perovskite tandem. And we're only at 17% now. I can't even believe I'm saying only 17%. It took us 15 years. We started at 0.1% back in 2000, and now 17 is mundane. But we're at 17, and we have a list of problems that we've identified, and we will fix these. The layer is just not thick enough. It's not absorbing the light. That's an easy one to solve, and we don't quite have the right band gap here. You have to get the band gaps just right because you need the same current in both solar cells. If one puts out less current than the other, it pulls the stack down. So we see some indicators that are a little too complicated to get into right now, that it's a very good material with huge potential. And so we think we're going to clear 25% soon in an all perovskite structure, meaning we can print the whole thing on plastic and have it be flexible. A year ago, these devices were very unstable. They were only lasting minutes. We couldn't even ship them to NREL for validation because they were dead by the time they got there. This was troubling me greatly. And then we have had tremendous progress. We did 3 things. We replaced the methyl ammonium, which was leaving the film, with a combination of cesium and formidinium. And then it turned out we were having corrosion with our metal electrodes. We replaced that with a metal oxide. And then we took advantage of being in Silicon Valley, and we just went to a nearby solar cell company, and they showed us how to do a proper package with a rubber edge seal. And with those 3 things, we're now able to pass the industry standard tests. There's a building full of torture chambers at a company called D2 Solar. Things like you put it in an oven at 85 degrees Celsius, 85% humidity, and leave it there for 6 weeks. And usually if you pass that, your cells will last for 25 years, even in a place like Miami. And we passed it on the first try. Another one, we have an oven on top of a freezer with an elevator that keeps taking the solar cells up and down, and so they shrink and expand, shrink and expand. And we made it through the 200 cycles, which is the test that you have to pass to be able to sell a product.
Welcome back to Green TV, the show dedicated to positive Green New Deal solutions and the candidates that advocate for them. Today we are continuing our feature on solar energy. I learned a lot putting this show together for you, and I hope you enjoy it. And now, more on solar energy.
Are you spending a large portion of your paycheck each month on a high electricity bill? Over the last 30 years, utility rates have continued to increase by about 6% per year. Unless you stop turning on your lights, using your kitchen, and washing your clothes, it'll just keep getting more and more expensive. And that's the bad news. But here's the good news. You have a choice. You can now tap into the sun's natural energy and use it to power everything in your home without having to write a big check to a power company at the end of each month. Here's how it works. Every day, sunlight will stream down onto your solar panels with photons, which are particles of sunlight. Then, the solar panels convert those photons into electrons of electricity using photovoltaic cell technology. The amount of electricity generated depends on the intensity of the sun, but even on cloudy days, your solar panels will still absorb sunlight and generate you energy. Once the energy is transferred from the sun, it flows from the solar panels to an inverter that converts the raw electricity into ready-to-use electricity for your home. You don't have to do anything. What's even better, solar electric systems can produce more electricity than your home needs, and the extra you do not use goes back to your utility grid. This is called net metering, and you'll be able to enjoy watching your utility meter spin backwards. Then at night or on cloudy days when your solar system is not producing enough energy for your home, you will be able to draw power down from the grid, so you never have to worry about running out of electricity. And if you are producing more energy than your household requires, then you'll get a credit from the utility company. You'll feel good about your solar investment, not only because it will provide you with a lucrative annual return that you can rely on, saving you thousands of dollars on long-term utility costs, but because you'll be doing your part in providing a safer planet for you, your family, and future generations. Best of all, it's a lot more affordable than you might think. If you're ready to stop wasting money on high electricity bills and start harnessing the free power that's available to you right now, just give us a call. Mention this video and our friendly team will be able to answer all your questions.
Renewable energy is free energy, and it's clean energy. Rail is safer transportation, and rail can run on renewable energy. Rail built anywhere in America benefits all of America. And that's it for today's Green TV. I'm Gail Farrell Parker, your host for today. Please join us again next time for Green TV and more on solar energy.